Welcome to English Learning Podcast, Throw Science.
Today, we're plunging into a topic that's, well, both incredibly fascinating and, let's be honest, a little terrifying. Tsunamis. If you've ever wondered about the sheer power behind these ocean giants, this deep dive is definitely your shortcut. We want to help you grasp what makes them so unique.
Yeah,
And, so devastating.
that's right. Because they are often misunderstood, aren't they? People think of big waves like surfing waves,
Exactly.
but tsunamis are completely different, just colossal forces of nature. So our mission today is really to distill the key insights from our sources, help you connect the dots.
Absolutely. So our deep dive today is all about peeling back the layers. What exactly are tsunamis? Where do they come from? I mean, the origins can be quite surprising. How
Definitely.
they travel across entire oceans, those crucial warning signs you really need to know. And we'll look at some major historical examples, too. You'll walk away with a much clearer picture, a really well-informed understanding.
Let's do it.
Okay, so to really get it, we need to bust some myths first. What, at its core, is a tsunami? It's not just one single wave, right?
No, that's key. It's a series of waves, and the defining thing is their incredibly long wavelength.
Right, wavelength. The distance between the crests.
Exactly. We're talking hundreds of kilometers potentially. That's huge. And that's why out in the deep ocean, they might just be a gentle swell, almost impossible to notice.
But then they hit the coast and it's a different story.
Completely different. And that long wavelength, it ties into why they happen. Unlike normal wind waves, which are mostly on the surface.
Yeah, just driven by wind.
Right. Tsunamis involve the entire column of water, from the seabed right up to the surface. It's usually triggered by some kind of sudden, powerful displacement under the sea.
A massive push.
A massive push. Think of it less like ripples on a pond, more like the whole pond suddenly tilting.
Okay, that's a great visual. So let's dive into those causes. The main one is earthquakes, yeah.
Yeah, the primary cause, the most common one, is definitely a big underwater earthquake, especially the ones at subduction zones, where one tectonic plate slides under another.
Okay.
When that ocean floor ruptures and shifts vertically, up or down, it displaces just an incredible amount of water, like cubic kilometers of water pushed around almost instantly.
Wow.
That sudden jolt is what generates that initial powerful wave pulse.
That scale is just... It's hard to wrap your head around. But it's not only earthquakes, is it? What else can kick these off?
No, not only earthquakes. Volcanic eruptions are another big one, particularly underwater eruptions.
Right.
Or, if a part of a volcano collapses into the ocean, that sudden dump of material or the explosion itself can displace enough water to create a tsunami.
Makes sense. And I think you mentioned landslides, too.
Yep, landslides are on the list.
Yeah.
These can be underwater landslides, huge slumps of sediment on the continental slope,
Okay.
or even large landslides from coastal cliffs crashing into the sea. When a huge volume of rock and earth suddenly enters the water, it pushes it outwards.
So can those landslides create the same kind of ocean-crossing tsunamis as the big earthquakes? Or are they more localized?
That's a good question. Generally, landslide tsunamis, while they can be incredibly destructive right near the source, especially in places like fjords or bays.
Right, contained areas.
Exactly. Their energy tends to dissipate more quickly over distance compared to those massive tsunamis generated by a major tectonic plate shift, which can, cross entire ocean basins.
Okay, got it. So once one of these things starts, how does it travel? You hear these incredible speeds.
Oh, the speeds are astonishing. In the deep ocean, tsunamis can travel up to 800 kilometers per hour. Seriously, like jet plane speed?
Wow, that's unbelievable.
But here's the crazy part. Out there in the deep water, the wave height might only be, say, half a meter or a meter.
So you wouldn't even notice it if you were on a ship?
Probably not. It's just this very long, low swell passing underneath. The energy is there, but it's spread out vertically.
Okay, so the danger comes when it reaches land. How does that transformation happen? That's the critical part, isn't it?
That is absolutely the critical part. This is where the physics gets, really dangerous for coastal areas. As the tsunami enters shallower water near the coast, the wave starts to feel the bottom. This friction slows it down, but all that energy it was carrying at high speed has to go somewhere.
Right, it can't just disappear.
Exactly. So as the speed decreases, the wave energy is compressed, and the wave height increases dramatically. It bunches up.
So it slows down but grows taller.
Much taller. Much, much taller. That gentle swell out at sea can transform into a towering wall of water, sometimes, 10, 20, even over 30 meters high when it hits the shore. This piling up of water, that's what causes the catastrophic flooding and destruction.
Right, and that leads us to warning signs. If you're ever near a coast, What's the absolute key thing to look out for?
Okay, this is vital. One of the most reliable and frankly eerie natural warning signs is the sea suddenly pulling back. Like a rapid, unusual receding of the water, exposing the seabed, reefs, fish flapping around.
Way further out than normal low tide.
Way further. If you see that, it often means the trough of the tsunami wave is arriving first, and the crest is following right behind it. Don't wait. Don't investigate.
Just run.
Run immediately. Get to the highest ground you possibly can as fast as you can. Your life could depend on it.
That's such clear, critical advice. Thankfully, it's not just about spotting natural signs anymore. We have technology now, right? Warning systems.
We do. And they've saved countless lives. Many regions now have sophisticated tsunami warning systems. These often use networks of sensors out in the ocean.
Like buoys?
Yeah, things like the DART buoys, deep ocean assessment and reporting of tsunamis. They measure pressure changes on the seafloor. So even if the wave is tiny on the surface, these instruments can detect it passing overhead.
Clutter.
And they transmit that data via satellite in real time to warning centers. This can give people crucial lead time, sometimes minutes, sometimes hours, depending on the distance from the source.
But getting the warning out is only half the battle, isn't it?
Yeah, absolutely. The technology is amazing, but then you need effective communication channels to get that warning to the public quickly. And just as importantly, people need to know what to do when they get the warning. Education and preparedness are key.
So it really comes back to us, to communities being ready.
Exactly. At the end of the day, quick action based on either natural signs or official warnings and understanding the evacuation routes and safety procedures, that's what saves lives. It really raises that question, how truly prepared are our coastal communities?
Yeah, a sobering thought. And when you think about the impact, some historical tsunamis just loom so large.
Yeah.
The 2004 Indian Ocean event, for example.
Oh, absolutely devastating. Triggered by that massive magnitude 9.1 earthquake off Sumatra.
Unbelievable scale.
It affected, 14 countries across the entire Indian Ocean? The sheer reach was unprecedented in modern times, and the impact went far beyond the immediate destruction, long-term displacement, psychological trauma, massive environmental changes to coastlines.
Just layers upon layers of impact. And then more recently, the 2011 tsunami in Japan. That one had its own unique set of consequences.
Yes, the Chuchoku tsunami. Also triggered by a massive quake, magnitude 9.0 or 9.1, caused terrible destruction along the coast, but it's inextricably linked in our minds with the Fukushima Daiichi nuclear disaster.
Right. The wave overwhelmed the plant's defenses.
Exactly. It wasn't just the wave damage itself, it was this cascading disaster. The geological event triggered the tsunami, which then caused a major technological catastrophe. It really highlighted how interconnected these systems are and the long-term consequences for, everything from energy policy to global disaster planning.
So just to kind of wrap things up from our deep dive today.
Yeah.
We've looked at what tsunamis actually are, these incredibly powerful, long wavelength waves.
Right, involving the whole water collar.
Their cause is mostly earthquakes, but also volcanoes, landslides. We talked about how they travel super fast in the deep ocean, but then transform dangerously near the coast.
Piling up that energy into destructive height.
And crucially, those warning signs, the sea pulling back, and the importance of warning systems and just being prepared.
Yeah.
So taking all that in, what's the bigger picture here for you, the listener?
Well, I think stepping back, understanding tsunamis gives us this profound respect for the raw power of our planet. These are immense natural forces.
Yeah.
But it also, highlights human ingenuity.
Mm-hmm.
Our ability to understand these complex processes, develop warning systems, build resilience. It's really about appreciating Earth dynamics and our ongoing efforts to live more safely alongside them.
That's a great way to put it. And maybe it leaves us all with a final thought to chew on. As we continue to learn more about these incredible events, how might that deeper understanding shape our future? How we build along coastlines, how we refine those warning technologies, maybe even how we think about our relationship with the ocean itself. Something to mull over.